Hello seniors, today we're going to see the continuation of arithmetic sequences, which is arithmetic series. The big difference between arithmetic sequence and arithmetic series is that arithmetic sequence focuses on each of the terms of the sequence, while the arithmetic series finds the sum of all of the terms in an arithmetic sequence. That's the difference between sequence and series. So, the objectives for this class, the first one, use the formula of the sum of the first n terms of an arithmetic sequence. And number 2, apply the arithmetic sequences to solve problems. Okay, so definition of an arithmetic series, as I already said, is the sum of the terms of an arithmetic sequence. So here's a demonstration of where the formula comes from. I'm gonna let you read this by your own. You don't need to know the demonstration for the exam. You will always have the formula available in the formula booklet. But if you want to see, I don't want to waste too much time during this video to show you the demonstration. If you want to see where the formula comes from, you may watch this video over here. I think you'll be able to click on this and it'll take you to YouTube and you will be able to watch the video. In case you're not taken to any link, you may write this into YouTube and you'll see the video. It's a 6-minute long video and it shows where the formula comes from. Okay, so the important thing you need to know is this part over here. This is the way in which you write the formula. Well, it's better if you see it here. If we go to the formula booklet, I'm going to show you how you see this same formula in the formula booklet. If we go to the formula booklet, you'll see that last class we saw how to find the nth term of an arithmetic sequence. And now what we're going to see is the sum of n terms of an arithmetic sequence. You see that you get this formula over here, which is actually two formulas, right? This is one way of writing the formula. This is another way of writing the formula, okay? So remember, we've already seen this during the last class when we did the exploration. And we're going to do a small example together in order for you to understand. But basically, what you need to know is that S of n is the sum of n terms of an arithmetic sequence. N is the number of terms. U1, as always, is the first term. N, number of terms again. D is a common difference. And if you're going to use this formula, you need to pay attention to this term, which is UN, which is basically the last term of the sequence. Okay. So, there's a question here, which we're going to answer by using this formula for you to understand. And maybe through this example, you will be able to understand the demonstration of this formula clearly. It says, what is the sum of the first 100 numbers? So imagine this sequence where we have 1, 2, 3, 4, and so on until we get to 100, right? So 98, 99, 100. And we want to find the sum of all of these numbers from 1 to 100. How do we calculate that sum? If you pay attention, this is something I already showed you last class. If you pay attention to the additions, you'll see that if we add the first term with the last term, the sum that we get is 101, right? Then what happens if we add the second term with the second to last term? We'll also get 101. And finally, if we add, for example, this term with this term, we'll also get 101. So the sum is always constant. And if we have 100 numbers, how many times are we getting 101? We're getting it half the times because we're always adding pairs of numbers. So if we want to find the sum of the first 100 terms, what we do is we divide the number of terms we have, we divide it by 2, because we're adding 50 times this sum, which is 101. And what we do next is we always add one term, or the first term with the last term, right? So first term with last term. So this basically gives us 50 times, we're doing the multiplication 50 times 101, okay? So the sum in this case is 5,050. So if you pay attention to this formula over here, you'll see that that's exactly what we did here. It's half of the numbers we have times the first term plus the last term. And if you remember the formula to calculate un, remember this formula over here, which we saw last class, un is the same as saying u1, the first term, plus n minus 1 times the common difference, right? So if we plug in this value of un into this formula, we are going to obtain this formula we have over here, okay? You see that we have the replacement done in this step. So we replaced, this was supposed to be un, so we replaced it by its equivalent, which is this formula over here, and by ordering the terms, we get this, which is the second way of expressing the formula for the sum, okay? So those are the two ways of calculating the sum of n terms of an arithmetic sequence. I'm going to erase this. This is this. Okay, so probably you're thinking, when do we use this formula? When do we use this formula? Basically, it depends on the information you have in the problem. If you're only given u1 and the common difference, maybe it's better to use this formula, right? Because in this case, you'll have u1 and you have the common difference. Now, if you're given, or if you can calculate the last term, maybe this formula is easier to use, right? Because it has less terms. It's only the first term plus the last term, then n divided by 2. So that's for you to analyze which one do you prefer. So let's go to one example. It says, calculate the sum of the first 15 terms of this series. Pay attention to this problem. We're only told that this is a series. We're never told that this is an arithmetic sequence. So we need to determine if this is an arithmetic sequence. So remember the concept of an arithmetic sequence. The concept of an arithmetic sequence is that there's a common difference between the numbers, right? So if we try this, remember, it's always the second term minus the previous term. So 21 minus 29 is -8, right? So the same thing should happen for these two terms, okay? 13 minus 21. How much is 13 minus 21? This is also -8, okay? So there is a common difference between the numbers. So the common difference is d equals -8, and we can conclude that this is an arithmetic sequence. So now that we know that this is an arithmetic sequence, we can apply the formula we just saw, or maybe this one, in order to determine the sum of the first 15 terms of the series. You see that in this case, we don't have the last term, which is un, right? So we will not be able to apply this formula unless we first calculate un and then use the formula. So I'm going to show you the two ways. One way is to use this formula. S of n equals n over 2 times 2u1 plus n minus 1 times the difference. This is it's basically this formula over here, okay? So we're applying that one first. So S of 15 would be 15 divided by 2 times 2 times u1. u1 is the first term, in this case 29, plus n is 15 minus 1 times the common difference, which is -8. Okay, so by plugging in these numbers into a calculator or by solving it manually, let's do this. This would be 15 divided by 2. We could leave it like that. 2 times 29, that's 58 plus 14 times negative 8. 14 times negative 8 gives us negative 112. So finally, the sum, I'm going to do it here. The sum of the first 15 terms of the sequence would be 58 minus 112 times 15 over 2. This gives us negative 405. So the sum of the first 15 terms of this sequence gives us a negative number, negative 405. Okay, so the other way of doing it, I'm going to do it in a different color, is if we first calculate un, which is u15, right? So let's do it here. If we calculate first u15 by using the other formula, remember the other formula is un equals u1 plus n minus 1 times d. So this would be u1, which is 29, plus 15 minus 1 times the common difference, which is negative 8. So if we calculate u15, I'm going to do this quickly. This would be 29 plus 14 times negative 8. This gives us negative 83. Okay, so the sum of the first 15 terms would be 15 divided by 2 times u1, which is 29, plus un, which is negative 83. So there we get s of 15, which would be 15 divided by 2 times 29 minus 83, should give us the same number, and yes, it's negative 405. So that's the other way of solving this exercise. Remember, in this case, we used the other form of the sum, which is this one. S of n equals n divided by 2 times u1 plus un. So that's the second way. Okay, so let's keep on with the next example, example 14 of the book. It says, find the number of terms in this series. So once again, we're not told what type of series this is, so we need to determine first if this is an arithmetic or another type of sequence, right? So we can try to calculate first the common difference between the terms. So 15.5 minus 14 gives us 1.5. Then this term minus this term, 17 minus 15.5, that's also 1.5. So it seems to be an arithmetic series. Let's do one more time. 18.5 minus 17, this gives us 1.5. So this is an arithmetic sequence with a common difference, d equals 1.5, positive 1.5. That means that it is an increasing sequence. Okay, so we want to find the number of terms. You see that we're given this last term over here, which in this case would be un, right? So by applying our formula, un is u1 plus n minus 1 times the common difference. So un in this case is 50, the last term. 50 equals u1, the first term is 14, plus n, we don't know how many terms we have, we want to determine that, times the common difference, which is 1.5. So we need to solve this, right? We can take the 14 to the other side. This would be 36 equals 1.5n minus 1.5. So this would give us, this would be 34.5 equals 1.5n. So n is 34.5 divided by 1.5, 23. So we have 23 terms, right? This would be the answer for part A. I'm gonna move this a little bit. So this is A, 23 terms. Okay, then for part D, it says find the sum of the terms. So we want to find S of 23. In this case, you'll see that it's easier to use this formula, S of n equals n divided by 2 times u1 plus un, because we're given the last term already, okay? So it's easier to apply this formula. So S of 23 would be 23 divided by 2 times the first term, which is 14, plus the last term, which is 15. So S of 23 is 23 divided by 2 times 14 plus 50. 736 is the sum of the first 23 terms of this arithmetic sequence. Okay? Let's move on with this exercise. I think this is the last one, yes. So, part A. Write an expression for S of n, the sum of the first n terms of the series 64, 60, 56. So once again, we need to first try if this is an arithmetic sequence. So we're going to find the common difference. 60 minus 64 is negative 4. 56 minus 60 is also negative 4. So this is an arithmetic sequence with a common difference of negative 4. Okay, so we want to find an expression for S of n, the general formula to find the sum of the first n terms of the sequence. So by applying the formula we already know, we can say that, you see that in this case we don't have the last term, so it's better if we use the other part of the formula, which is n divided by 2 times 2u1 plus n minus 1 times the common difference. Remember, this formula is available in the formula booklet. It's this one, okay? You don't need to memorize the formula. So, we're going to apply the formula. S of n, which is the general formula, would be n divided by 2 times 2, u1 in this case is 64 times 64, plus n minus 1 times the common difference, which is negative 4. So we can organize these terms in order to get a better looking formula. So this would be n divided by 2 times 2 times 64, that's 128, minus 4n plus 4. If we keep on doing this, this would be n divided by 2 times 132 minus 4n. Finally, this would be S of n equals, if we do the distributive, this is 132 divided by 2, 66n minus 2n squared. So this is the formula, the general formula to find the sum of the first n terms of this particular arithmetic sequence. Okay, then part B, it says hence. Hence means then. That means that we're going to use this answer we calculated in part A. So hence, find the value of n for which the sum equals 0. You see that the common difference is a negative number. That means that this arithmetic sequence is decreasing, right? So there will be a point where we're going to start having negative numbers, I don't know, negative 10 and so on. So the sum would start decreasing, and there will be a part somewhere in this sequence where the sum would become 0, right? So where does that occur? If we want S of n to be 0, we're just going to use this formula we just calculated, and we're going to set it up to 0, right? 0 equals 66n minus 2n squared. Okay, so there are multiple ways to solve this. I'm going to show you two ways. The first one is by factoring these terms and without the use of a calculator, right? Which is better. It's always better if you try doing it without a calculator. So how do we do this? You see that we can factor, there's a common factor which is 2n, right? So we're going to get here 33 minus n. So if this is set up to 0, we have a product of two terms, right? That means two things. That 2n may be 0, which will give us as an answer n equals 0. And the second possible result would be that this product should also be 0, right? So 33 minus n should also be 0. And that gives us a result of n equals 33, okay? This result, the first one we got here, is not valid, right? Why is it not valid? Because we cannot have 0 terms, right? N equals 0 is not possible. Remember that n should always be an integer number, a positive integer number, 1, 2, 3, and so on. It could never be 0 or negative. So we're going to discard this result, not valid. So the result would be n equals 33. So if we add the first 33 terms of this sequence, we should get as a sum 0, okay? We can always try that. I'm going to do it with a different color. Let's write it, validation. If we try to find s of 33, the sum of the first 33 terms of the sequence, by applying the formula, I'm going to apply the original formula. This would be 33 divided by 2 times 2 times u1. u1 in this case is 64 times 64 plus 33 minus 1 times the common difference, which is -4. If you solve this by using the formula, the calculator, just to not waste too much time, you're gonna get 2 times 64 plus 32 times -4. This gives us 0. So this is correct. The other way of solving this, if you want to use your calculators, I'm gonna make a division here. So I'm gonna make it with a green color using GDC. This is only valid for part B of the exercise. If we want to solve this equation using our GDC, that is 0 equals 66n minus 2n squared, you see that this is a quadratic formula, right? So we can organize these terms and have 0 equals -2n squared plus 66n, and then we have a plus 0, right? There is no independent term in this case. So if you use your calculator, remember it's menu, equation, and then you're gonna go to, I'm gonna show you steps right here. So this is your calculator, right? So you're gonna go to menu, equation. In this case, it's a polynomial, right? Polynomial is f2. Degree 2 is a quadratic. Degree 2. And then we plug in the coefficients, which were -2, 66, and 0. Okay? Then you press execute, and you get the two values. N equals 33, and n equals 0. Okay? So menu equation, polynomial, degree 2, then you plug in coefficients. Plug in coefficients, and you get n equals 33 and n equals 0. But this is not valid. So this is the result, okay? So this is how you would solve this using the calculator. Okay, so I hope you understood this lesson. If you have any questions about this, don't hesitate to ask in the Google Classroom. I will always be available for you there.